All right, everybody, hello and welcome back. Today what we're going to do is we are going to talk about a new concept called the average rate of change. Now, although average rate of change is a new concept for us, it's very similar to slope. So what we're going to do is we're going to start off by activating some prior knowledge here and discuss the slope of a linear function. Many of us will recall that the slope of a linear function is constant throughout the entire function. There's numerous different ways we can calculate this slope as well. If we are in a familiar form, we can simply look and find out what our slope is going to be. So when we're given the equation, we can usually look at the equation and pull out what that slope is. We can also do it from a graph. And now we do it from a graph by finding the 2 points of interest, let's say this one and this one, and then finding the difference in their y values and dividing by the difference in their x values. That really just means finding the rise and then the run. So in this case, the slope is going to be my rise divided by my run, which is going to simplify to -1/2. And now we should know with linear functions that no matter what 2 points we are determining the slope between, the slope should always be constant. So even if I chose, let's do a different color here, this point and this point, the slope should still come out to be the same. So just real quick to show you, we're going up 1, 2, 3, and then over 1, 2, 3, 4, 5, 6. So our slope there would be our rise over our run, which again simplifies to -1/2. All right, so we can pull the slope directly from the equation. We can use the graph to essentially find our rise over run, but then we can also calculate the slope if we were just to look at table values. Now, the equation we use to calculate slope is y2 minus y1 divided by x2 minus x1. One value, 1 point, is represented by these two values, and the other is represented by these two. So for example, let's say I want to use these 2 points here. One of them is going to represent my x1 value and my y1 value. The other one is going to represent my x2 value and my y2 value. All I have to do is plug into this formula here, and I can calculate the slope. It doesn't really matter which one is my x1 and which one is my y1, as long as my x1 and y1 come from the same point. So in this case, if I just plug right in, I have 1 minus 3 divided by 3 minus -1, which will simplify to -2 over 4 or -1/2, which is the same slope we got from looking at the graph and from looking at our equation. So it should be something we are pretty familiar with. However, not all functions have a constant slope. That's where average rate of change comes into play. Average rate of change is essentially the slope between any 2 points on any function. And there's a formula that we are going to use, which looks like this: f of b minus f of a divided by b minus a. If you notice, this is very similar to this formula here because it's essentially the same. All these values come from, well, if we have an a value, it's our input, then our output would be f of a. That's 1 point. The other point, let's say we have an input of b, well, the output would be f of b. So all we're doing is, once again, we are subtracting their outputs and then dividing by the subtraction of their inputs, which is exactly like what we did over here. So here's an example. We have a quadratic function here. P of x equals 1 over 3 times x minus 4 squared minus 3. Now, a function like this is quadratic, so it doesn't have a constant slope, but we can still find the average rate of change over an interval or between any two x values. Let's say I want to find my average rate of change between an x value of 1 and an x value of 7. Well, let's just look at the graph. we've got an x value of 1, which is right there, and an x value of 7, which is right there. So I am trying to find the slope between these 2 points. Well, if we have the graph, all we have to do is connect these 2 points and then find the rise over the run. We should be able to recognize that our average rate of change, or AROC, sometimes it's called, well, the rise is nothing. We're not going up at all. It's directly horizontal. And then the run is going to be 6 to the right, which means 0 over 6 is 0. So the average rate of change over the interval from 1 to 7 of this quadratic function is 0. And that should make sense. You know, what the average rate of change is it is essentially the average of all of the slopes in between. So for example, there's a slope there, there's a slope there, and there, and there. But then there's also the other side. So on the left side, those are all negative slopes, but on the right side, these slopes are all positive. And since both sides are equal, it should make sense that our average rate of change is 0. All right, so it's pretty easy to find the average rate of change for any function when we are given their graph. All we have to do is put points on the x values we are interested in, draw a line to connect them, and then find our rise over run values. Let's take a look at a new example. We have g of x equals 1/2 to the x plus 3 power. I've got a table of values, I've got a graph, and then this is the interval we're going to want to find our average rate of change from. Instead of just looking at the graph and connecting those 2 points and finding the slope, why don't we just focus on the interval? So let's just pretend that we are only given the equation and then the interval for which we wanted to find our average rate of change. Remember, average rate of change is essentially just slope between any 2 points. Well, I need points to calculate the slope. So if I've got my input values here, all I have to do is plug them in one at a time to get their corresponding y values. So if I'm going to plug in -6, when I plug in -6, I get out 8. And then I can do the same thing with -3. So I've got 2 points, -6, 8, and then -3, 1. All I have to do is calculate the slope between those 2 points. So we are going to find the average rate of change by subtracting their y values. So I'm going to do 8 minus 1, and then I'm going to divide the subtraction of their x values. -6 minus -3. And as a reminder, just like the slope of a linear function, these 2 values need to make up 1 point, and then these 2 values need to make up the other. So if I subtract them, I get 7 over -3. So the average rate of change between the x values of -6 and -3 is -7/3. Just to kind of confirm that visually, what I can do, so I can go to -6, I can go to -3, draw a line between those 2 points, and then calculate the slope. I'm going up 1, 2, 3, 4, 5, 6, 7, and then to the left 1, 2, 3, and since it's to the left, it is negative. So our average rate of change is in fact -7/3. Okay? Average rate of change is very similar to slope, but we can find the average rate of change regardless of what type of function we are dealing with. Okay? As always, thank you for listening. If you have any questions or concerns, please feel free to reach out. Thank you.